welcome to all our viewers to an enriching knowledge series on facade and fenestration. Facade and Beyond, presented by Timexbond, ACP HCL, Architectural Ideas Personified. Welcome on board for an intrusive and interactive discussion on advanced facade, parametric design and innovation. Let us gain more insights from our eminent panel with rich experience from the build and design industry. What are the new design concepts and techniques and innovations, computational design, parametric facade, and more? Joining us today for this perceptive discussion are Architect Khushbu Davda, Studio Emergence; Architect Shakti Parmar and Associates; Architect Ali Abbasi, A-Cube Architects; Mr. Gautam Bhasin, InHabitat Group; Mr. Jinesh Gala, Timexbond. I hope we have a very informative and knowledgeable discussion. Before we start with the panel discussion, we would like to play a short AV, and thereafter, Architect Khushbu Davda will be taking it ahead. Thank you.
Hello everyone, we are here for the seminar for iDAC, Advanced Facade and Parametric Design and Innovation. We have a prestigious panel today consisting of Architect Shakti Parmar from Shakti Parmar and Associates. We have Mr. Jinesh Gala from Timexbond, Mr. Gautam Bhasin from InHabitat Group, Mr. Ali Abbasi from A-Cube Architects, and myself, Khushbu Davda, from Studio Emergence. Hope we have an informative and fun discussion. We're going to be talking about lots of things apart from just parametric designs. We're going to be talking about the future of facades and construction in India. Let's have a very, very informative discussion. We are going to be starting with our very, very veteran and very reputed architect, Mr. Parmar. We wanted to start the discussion about why we would, what is a whole buzzword about parametric architecture, computational design that has been used in the recent past in the industry, and what are his views on why do we need to take a step back and evaluate our construction method up till now. Mr. Parmar, we would like a few words on this.
See, as far as the architecture is concerned, I personally feel, and this is, I must tell you how I was inspired to take up architecture. And when we were in school, the word architecture was not even taught in the school because I was going with the Hindi medium. Anyway, in one of the processes, I happened to hear about Frank Lloyd Wright, and I happened to see the Falling Water Peace Project. And that's what it inspired me that I need to, there is something like architecture which, as far as I'm concerned now, what my philosophy, not exactly we call it a philosophy, it's a way of thinking, that this is a mother earth, and whatever we do here is we are intruding into it. And we have the whole universe here, whole earth is here. It has its own purest possible form. It has its own vegetation. It has some millions of beings there. And we happen to be with a little extra brain, and we are intruding into it, and we are disfiguring it, and we are not, I mean, not exactly disfiguring it, but we are not allowing it to be the way it is. Now, see, you see a nest. You see the birds, they pick up the twigs and they make their nest, and they have their family, and they have family, and then they've flown away, and the nest is not there anymore. And the earth is as pure as before it was. That's what I would like. I would like to be, since we have extra brain and we have to, I mean, we have been progressing it. We have been, to me, the history and the tomorrow and the yesterday do not have much value to it. So it's a purity of earth which we need to maintain it, which we need to have the architecture which belongs to us, and which is just for us and not for coming 5 generations. Let the generations think of themselves. To me, even Taj Mahal had no meaning to be there. Anything you build, it occupies the space. It has disturbed the Mother Earth, and it's going to be there for hundreds of years. I believe that everyone has a right to live in, like we are being, maybe with a little extra brain, a little different way of living than the millions of other beings which are there on that vegetation which is there on Earth. So we should do something which just belongs to us till we are there, and then the next generation has its own way of looking at it, has its own way of developing it. The way we should not be forcing it on the next generation. So that's exactly what I look at it. Even in my architecture, the first house which I built in Bangalore, I mean, unfortunately, I don't have the image of it. That was after I did my architecture. I stayed as close to the earth as possible. I went and picked up the stones myself as per the natural sizes. I did not even cut them. I left them as it is. I had the labor involved and built that house, and it's there, and it's on the Sankey Road, Bangalore, and Dr. Deshpande's house. And fortunately, the clients were all with me, and the budget was almost none. I mean, we were building there. It's a doctor couple which had come from England, and they're establishing themselves. So build. Now, you see, if you look at the house, you remove the house, and you will not feel that you have disturbed the earth, that anything which was there, which has been removed from there. That's exactly.
Yes.
Although,
exactly. So taking cue from that, I would like to hear a couple of more insights on what do you think about the buzzword parametric architecture. I think he has put a great light on how materials are used very differently, used with a lot of resources are used, and the life of the building is so much that new technologies are not allowed to be built or adapted very quickly. So we would actually like some other insights also from the panel. Mr. Bhasin, could you take that, please?
See, sure, certainly. I mean, we belong to the present, and we will belong to the future also, and we belong to the past also as well as, and we are going to be there, and we do need a nest to live in. That's what it is. And in terms of the materials are concerned, I personally, as far as possible, I try and be as natural as possible.
Yes.
And but you cannot be completely natural, because we have run into the plastics when we run into the different materials of that, because the science has increased, and and we are all hypocrites. It's only the degree of hypocrisy differs from that.
Yes.
I might be talking all this, but at the same time, I might also be using the materials which belong to today and which will belong to tomorrow.
Yes.
But and as the science is going with us, as the history is going with us, as the literature is going with us, so we have to try and keep in as much balance as possible. Try and not to disfigure this earth as much possible and try and not to grow too much. We are growing a little too fast.
Definitely.
That's
Definitely,
so
sir. We should be adopting newer technologies, more sustainable technologies in the future, because population is going to grow and we will need habitat and we will need other buildings. So for sure, we'll have to be mindful about what we do in the future. So
now you even today you go and look at the falling water Franklin Wright's work. It just belongs there. And it is a house and it's there, but it's so beautifully made. Of course, that scale was different, that need was different, and that thinking was different. That cannot happen. We are millions of us, and we need to be housed. But we should occupy the Mother Earth as little as possible and for as little time as possible. So the next generation, it's like the kids going on the sea beach and making their own sand castle. Now they sit there, they play with it, and they make that. They say, "This is my room. This is your room. This is how we will live." All that will happen, and they're done with it. Now, the waves come and it's not there. Now, next day, the next set of people go there. That's exactly is I would like to happen around here. I mean, it may happen, it may not happen, and probably it's not practical to happen. Maybe it is also practical to happen, but on a small scale or a large scale or even a universal scale, if the thinking is basic, then we should not be doing anything for a decoration, as if basically just for to look at it. When I do my building, when I do my spaces, when I design with the people in mind. I never design a house or never design a space where I don't feel the people who are going to be in it. So the space should belong to the people and vice versa. That's exactly how it has to be. So that comes to the smallest possible details when you do that. And then the architecture also lives in along with the people, because when you have thought of it along with the people, it will live with the people.
Yes, so definitely, sir. I'll get back to you again. I would request Mr. Ali Abbasi to give in a few words regarding this. Regarding how we can change the future using new technology and adapt ourselves to newer construction methods, which will not affect the environment and people living here as much as we have been wasting up till now.
I think environmental consciousness is there with newer building materials. Everybody, all construction companies who are manufacturing new products, everybody is trying to come up with products which are environmentally friendly. And but the requirements are changing. We need to do a reality of population increase. We need to have skyscrapers. We need to have bigger buildings happening. So we have to use newer technologies, newer materials to adapt to that. But at the same time, we need to think about energy, also conserving energy and utilizing just enough what we require so that we can sustain the building, and it's more viable for the user as well as it's good for the environment. So that balance is very crucial, and I think the newer products that are coming up in construction are keeping that in mind in terms of environment, health, safety. All those aspects are looked into.
That's completely true. I think we have a varied panel today, and we'll be able to go into detail on each of these aspects also. Why don't I do this? I will do an introduction presentation on some of the stuff that we're going to talk about, and then we'll go in depth with the experts also. So let me introduce myself. I'm Khushbu Davda from Studio Emergence. We are a parametric design and a consultancy firm. We also deal with a lot of architecture and facades. So I will be sharing some of our projects with you guys today, hoping you will enjoy that. And also, if there is any question, you can always ask us at the end of the presentation. We'll be happy to answer all of those. So we have come a long way from being master architects to from doing everything in the last century, from design, construction, being structural engineers, to now having experts for everything, from our design, which is completely done by architects and a conceptual design team, from rationalization, which is done with the structural engineers. There are technology experts, robotic experts, then there are obviously material experts who actually not only manufacture but also help in the assembly. So there are a lot of people involved, and only creating a team which is an expert in everything will actually help the future. So that is what we think is the future, because the project scales are increasing day by day. And if we want to ensure that we are creating really high quality projects which are taking into consideration all of these parameters, that is completely required. Collaborative practice, up till now, what we thought is, where an architect or a designer is working on a CAD software or a 3D modeling software, where there is a schematic and a design development stage happening, then there is a working drawing and a client approval. This is the design process up till now. But with the help of these newer technologies, which is called parametric design approach, what can happen is there can be a feedback loop in such a way that all of those processes which are actually a little which require a little bit of intervention, where there are some side changes or there are some programmatic changes which require changes in the design itself, this can be algorithmically approved in such a way that you decrease the cost of decrease the time, whereas which also leads to a decrease in your cost. Because the most important aspect in any of your building construction is A, material, B is the timeline. So if those two things are taken into consideration, parametric design or BIM technology, both of these, when they work in a feedback loop, the output that comes is the most optimized version of the design process. So this is what I wanted to try to explain, that when BIM was completely new, the early adopters actually gained a lot from BIM technology, because they could actually create really informative 3D models, which actually helped in the final construction. What parametric design does is actually help even those BIM components, which makes it adaptive and creates a whole system, which is like almost a virtual system, which can be adopted in the real construction. So the first thing on the drawing board which you do is called the ideation, which happens only in the drawing board, where your architect or your structural engineer and all of the people involved, even the client, is actually involved in the ideation stage. When it comes to the implementation stage, we involve the other vendors also of what all can happen. So once everyone is on board in the implementation stage, then you also want to educate, because once there is more awareness of why you are creating that kind of a feedback loop system throughout the entire ecosystem, there will be more and more adopters of this kind of technology. So this is an example of what we did with this kind of a technology. You can see this project, it's the Andheri metro station, which is coming up in line 7 in Mumbai. So what we did here was actually just the facade. You can see there is a standard prototype of these portals which are coming across Mumbai. So there are these arched portals which you can see in the center. And all of there are 4 metro stations actually that were given out by the MMRDA as a competition, design competition. So we have won this Andheri metro station. What was the concept behind this was, usually when a metro station of this kind, any infrastructure project of this kind comes up in the middle of the city, the privacy of the buildings around it is really hampered. So what we thought, why not take that into consideration of the people who are actually living around that right now. So if you see these apertures, we have given it in such a way that they are directly, the size of that is directly proportional to the distance from the buildings. So if you see this, these two sides, there is the buildings are very close to this. So the aperture sizes are really small, so you can't hardly see anything inside. Whereas if you see over here, there is no building on each side, so the aperture sizes are big, which also results in giving a very dynamic looking structure and creates these kind of dramatic shadows, which can create a pattern on the inside of the station. And we have given these glazing details, and the different sizes can be of course fabricated digitally and added on the facade of the metro station. We are hoping that this will finish construction to 2021. So going to optimization of form. Now we already saw how we can actually create privacy with the help of these kind of technology. Optimization of form is really necessary. This is a building in Marol. It's called Raheja Platinum. This was done in conjunction with IAG Architects. We were the parametric consultants for this. For this, what was the problem was this building was almost already constructed, and we had to do this Korean cladding on top of this. Now, Korean, you all must be aware, is a very expensive material. So creating an optimized version for this building was really important, especially because the water tank and everything was already built. And the original design, which was proposed by the architect, was not really fitting in this because there was some mistake on the side with regards to the OHT. So it was coming a little outside. So it is a very common phenomenon. We have always seen that Indian contractors, there are always some mistakes on size, and of course it's human. So how do we correct that? To do that, what we did was create an optimized optimization algorithm in which we actually took into consideration the panels which are doubly curved and singly curved and flat panels. And we optimized in such a way that the doubly curved panels, which are the most expensive and you have to thermoform them, those are the least in number, so that the cost can be obviously really cut down. And the rest of the panel, which you can see in blue and green, they are all flat panels or singly curved, which are relatively much less expensive. So we had to redo the entire thing and then clad, which was a shorter process compared to the ones they were doing earlier. They could complete building in a shorter span and also reduce on the cost of construction. These are some construction images. We also did the canopy for that, but this was from scratch. So we could we had the free hand to do any design which was possible. And of course, we have used Korean. So doubly curved surfaces are very easy to do with Korean. So this is how the building is completely constructed, and right now we work has occupied this building. Same material, different small resource. We understand the material with the help of these smaller prototypes. We have done this interior apartment where we use the same technology. You can see this in a seat. It looks like a marble flowy seat, but it's the same material as you saw in the building. This is just for that. Similarly, what we do is we keep on doing these experiments to understand what we can use in a facade. These are cement composite panels which we have created for an urban installation. This is outside a museum in Visakhapatnam. Is one of the most famous museums, which is the Aircraft Museum, and there's a submarine opposite of that. This is a very widely used public space. So we have created these really colorful cement panels. This can also be used on facades. So this was an experiment done with Nerolac for the CSR projects. We do a lot of these experiments because form finding is something which is really required at the conceptual stage. If you don't do that, you don't really understand how the structure can perform much better than it used to. So there's a lot of parameters that can be taken into account depending on the context of the project, obviously. There is solar, there is a structural component, then there is panels, because the panel sizes of say glass or ACP or any material which we use, they are all fixed. So if we have that panel component also as a parameter, we can actually create the structure in such a way that the panel sizes will be optimized for that, similar to what you saw in Raheja. So, so there are all of these different techniques we use. I'm just going in really short because we have limited time. Again, similarly, we are doing this project with IAG consultants where the building core is already made, the basement is already made, and the function of the building actually changed. So you can't really go back to the drawing board to understand what can happen. So what we have done is, with the help of this technology, we have optimized what all you can do with the facade. So we have given like these 3 options with the same kind of same column placements. Actually, the columns only change on the upper floors, and there are different possibilities, you know, a lot of possibilities which you can do with that building. This is a commercial project. It gives a more free hand to what you can do. This is a residential project. Again, this is a redevelopment project. This is done by us, and we are doing it with Sugi Group. And redevelopment project, if you know, it's a very complex puzzle. So you can't really do much with the facade except for balconies. So it's a complex puzzle, and you can see like a framework of the building, which is done in with the help of BIM. And what we have created over here is an apparent dancing balconies. So when you go from Gokhale Road, which is a very central road in Dadar, you can see these dancing balconies in the form of, you know, these lines. And we have created those. And what happens with this technology is you can actually optimize or keep constant the size of the balcony. So suppose if the developer wants the balcony size to be 60 square feet for all the apartments, you can keep the size constant and just change the shape to create like such a dynamic form in the facade. So there are a lot of possibilities which can be created with a facade. Even a simpler version like a tessellated facade, which is only optimized for sunlight. So wherever there's more sunlight coming in from the south region, you can increase the size of the balcony and you know, create these metal jalis, which will create like dynamic shadows inside your balcony. And the rest can be simple. The rest of the building, it's as a Mumbai DCR is very strict, so the rest can be you know, kept very simple. For emergent patterns and solar optimization, of course, climatic intervention is the most important. So while we do a lot of studies in what all we can do with the facade technologies, what we have done is try to understand how, if we can create new components which in different materials, which can help in doing that, which can help in actually creating facades which are dynamic looking, but not necessarily moving. Now, you definitely have a lot more economics when it comes to countries like Dubai, where the facades can, you know, afford to be moving, whereas in India we haven't reached there yet. So what we have tried to do here is try to understand optimization, that in a given region, if you want sunlight to come in maximum during the winter and minimum during the summer, how do you do that? So this experiment was for that. And you can see here it can be, you know, applied to a larger scale module of, say, a commercial or institutional building. So we did a small prototype to understand this. We have used this sine curve, which was a self-stable curve. There was no support required for this. And these cones are all digitally fabricated. All these are completely different in size. Each cone is to create, which gives you this dynamic shape. So there's a lot of prototyping and a lot of experiments that are required. At the end of it, you get a much more better performative facade, which will give you a building which actually breathes with your with the humans that are actually inhabiting it. Yeah, so that's how I want to conclude. I want to just conclude saying that collaborative practice is the future, and unless we all come together to create better and even more informative buildings, we won't be able to get in a position where we will be more sustainable and we will be using less resources as possible. That's how I want to conclude. Hope this is a nice introduction, and we would like to take this introduction forward to Mr. Ali Abbasi. He's a reputed firm A-Cube Architects, and he has a large body of work, and also related to parametric architecture. He's done a lot of work in this field, and we are really excited to see some of his projects today. I would request Mr. Ali Abbasi to share his screen and share some of the projects.
So, thanks for the nice introduction, Khushbu. Let me start just giving a small gist of what we think is parametric architecture. And you ask many architects, everybody would probably have some kind of a different definition. And it's due to the fact that there's a wide-ranging definition to it. So it's a facade in which the parameters are set, and they have a certain logarithm that is there. And the parameters can be daylighting, heat studies, airflow, and these parameters are basically analyzed and modeled using softwares. And we can conceive forms that were, previously impossible to, impracticable to execute or to imagine. And it's also because of the advent of computers that we're able to, probably attempt to do these kind of complicated forms. But at the same time, there is an improvement in increase in the ease and the economy of fabrication of some of the more newer construction materials. You have solid metal sheets, aluminum composite panels, FRP, GRP. You have, as you said, Korean and these kind of materials which are more easy to fabricate and to construct. And the software that we are talking about that is used to design these parametric designs are also the same software. It's a single digital medium which is used to control the heavy duty industrial materials, CNC cutting machines, and other machines that will give you the accuracy and performance for doing a parametric facade. So overall, by using a parametric facade design, you ensure that the facade has optimal light, solar gain or solar shading wherever required, and you have optimization of material use because materials are used more economically and with minimum wastage. And over and above, you have a unique building which gives a very different aesthetic to the entire project. Now, I'll just run through some of the projects that we have done in our practice where we have attempted to work with parametric designs. And these are wide-ranging. We've tried it in clubhouses, in malls, in industrial offices, and also in site offices, parking buildings. So we have, in our own way, with whatever constraints are there, we've tried to come up with unique designs which have parametric design in them. So this is a mall that we have done in Kolkata. It is designed in Kolkata and under construction, where we've used tessellations. So tessellations are, it's a skin where we have various different sizes of cutouts having, sorry, I'm going too fast, maybe just go back. Yeah, we've used different sizes of openings to ensure that the privacy and light that is coming into different areas is different. And we have a play of light and volumes. And the retail areas where we want maximum visibility, we've actually created more openness over there. And the whole building has a different identity. So the point was to create, a very different identity for the building, which would be, an attraction to the end user. This is a clubhouse that we did the facade for, and it's a double skin, and it had a multiple mix use. So you had banquets, you had gyms, you had tennis, badminton courts, squash courts, lot of different activities, which each activity having a different use and a different light requirement in each of them. At the same time, the entire facade had to be seamless and to be integrated. So this is where we've proposed an entire facade with these openings and fenestrations, and it creating an entire wrap around the entire building. This was an office building that we've proposed for an industry where they wanted, again, to have, you know, a building which would showcase the forward, modern-looking thought of the industry. And we've come up with a facade where, you know, we've ensured that the spaces, the office spaces, require a certain light lux level, whereas certain spaces, like where we do not require too much of light or heat, and plus we modeled the whole thing and seen based on the sun path of the amount of light. So we have these folded planes which actually allow the amount of light entering inside. We have this atrium at the entrance which we wanted visibility and maximum light coming in. So along with the modeling and the orientations, we've entirely designed the facade to have these panels which also, you know, give play with the light as well as also give a sense of you know, motion to the whole building, and it's optimized to an extent that the wastages in the facade are minimum. This is another retail building where we've tried to have some, you know, cutouts and fenestrations and create openings to again give different purposes, you know, of visibility, light, and solar heat gain into the building. This is a very interesting building that it's a site office, which normally every project has, and site office and a sample flat. But we wanted to create an identity for this new project. So we actually use the logo of the building, because logo of the builder, of the developer, and we use that as the, you know, fenestration on the facade, and it's got varying sizes so that it also creates a sense of recognition for his brand, and it wraps the whole building. So it kind of you know, creates this very exotic entrance which entices his, you know, customers to come into it and have a look at what's inside the building. So other than the normal you know, light and other benefits, we've also got a very interesting looking facade. And in the night when we light it up, the light adds another element to this whole building. And this is the executed picture of this building. So this is another building which was a parking block of a tower. And the developer was very specific in saying that he doesn't want to do a conventional facade for the parking block. So we actually have come up with these fins which are varying in their curvatures, which in their own self, they create this volume within. And we've played with the colors on the block so that when you drive past, you have this splash of color happening. And the entire form that is created with these planes. The interesting part is that we had worked out where we've actually used, you know, very normal construction Siporex blocks, cutting them, you know, into with accuracy, with the help of, you know, getting these curves and in the entire facade, and working this out in a very cost-effective and a very achievable way. So the whole point is that we want to do it, but with respect to the cost and to, you know, make something buildable. It requires that we do that value engineering to make sure that we can achieve these things in buildings. Yeah, thank you.
Yes, definitely, sir. And it was lovely to see all of your projects. We'll be doing Q&A after this, where we'll be asking you a lot of questions on these projects too.
Sure, thanks.
Yes. I would request Mr. Gautam Bhasin, who is from InHabitat Group, which is an international facade consultancy group, to take it from here.
Right. Thanks, Khushbu, and thanks, Architect Abbasi. I think those are some really wonderful projects, and I think thanks for setting the tone right for the discussion. There were a lot of conversation around how parametric designs used to actually achieve some of these really fantastic forms of very organic looking fenestrations or apertures on your external skins. I'll just share one example of a project which actually has its own complexities given it's super tall. How does parametric design help achieve construction and cost control over the project? So I'll touch upon some of the areas of how does parametrics actually help post design completion. So trying to make facades or trying to make building on enclosures more manufacturable, because end of the day, you can have a very nice organic looking building, but then the success of it depends on how easily it can be manufactured, because you get materials in standard panel sizes, standard sheet sizes, and there's very little playroom for you to basically achieve a very organic form in sort of very limited available sizes. The project that I'm talking about, it's called Patamine Energy Tower. It was sort of an oil-driven development. So we had completed the design, and then because of oil boom and then subsequently oil bust, it basically went belly up. But it's a very interesting design story nonetheless. So the project is a compilation of 4 or 5 buildings, with the centerpiece, that's this building, which is about 523 meters, close to half a kilometer in height. Now, what may look like a very standard extruded form has some complexities to it, because anything that's super tall these days is almost a competition of being able to design a beautiful perfume bottle. It's got these twists and turns and curves where it's sort of changing form as it goes up. So it's not a very simple extrusion. It also needs to be aerodynamic for it to become very smart from a wind perspective. So it's designed intelligently with an aerodynamic form. But while all that sounds really great from an architectural perspective and from a wind engineering perspective, it starts making life difficult for facade engineers. So what appears to be a building that's a straight extrusion for the bottom 2/3, it starts changing form on the top 2/3, where there's a sine curve which gradually makes the floor plate reduce its size, but it also starts to lean back. So it's obviously forming like a double curve surface. And double curve is considered a bad word in facade world, because every time you talk about double curving something, which means thermoforming, something that we heard in Khushbu's presentation, or tessellating or triangulation or other methods which either are an aesthetic compromise or they're frightfully expensive, and that starts really getting some weird reactions from the owners saying that we don't want to spend so much. So what happens in the top 2/3 or top 1/3 of the building, which is a typical high-rise building, it's about a 200-meter tall tower in Mumbai, placed on top of a 300-meter tall tower. So it's a building above a building almost. So what's happening in this part of the building is that it's reducing, it's basically leaning back, but also becoming smaller in shape. So it's almost forming this double curve surface. And if you try and use flat panel geometry, which is any material you talk about aluminium, you talk about glass, you get them in flat panels. And the minute you start to put flat panels, you'll suddenly start seeing this little shift that happens, which is what we call as fish scaling on a double curve surface. So we figured out, okay, where do we start and what are the options, what are the alternatives, just so that the client can take a well-informed decision. So when you try and imagine a big gym ball and you're trying to take playing cards or business cards and trying to cover it up, you will start seeing a pattern like this emerging, where one corner can be joined, but then when you start pushing it closer to the surface, you start creating these triangular gaps. So with that, sort of a standard panel with floor-to-floor height of about 4.3 meters, panel modules of about 1.5 meter centers, we started looking at what are the alternatives. How can we make this building airtight, watertight, highly manufactured? So this is very, very modular. It's all panelized, comes from a factory, where you can't have the opportunity of sealing the building from the outside 300 meters up in the air. So what are our options in this case? To wrap around a double curve surface, we basically looked at 3 aspects, which are obviously very important. One is feasibility. Can someone actually fabricate that? Second is, what is the impact on aesthetics? Because every time an architect develops a render, the client is sold on the vision. They know that they would want the building to look exactly like that. And then third is you have to really buy the material, you have to buy the product, you have to buy the facade for the building. So it should still be in some reasonable cost and should not cost you an arm and a leg. So the first option we looked at was to triangulate it. Very simple. You have seams, you fold it over, and then you can create that triangulated surface. While it's feasible, the aesthetics go for a toss, because try and imagine to be inside a building, in an office building, where every panel has like a diagonal, which is a very weird experience from inside out. Outside in may not matter as much because it's sitting really high up in the air. And the cost is sort of still sitting reasonable. You can thermally curve it. It will literally cost you a couple of organs of your body, where you have to thermoform double glazing, thermoform aluminum extrusions, very, very, very expensive. Aesthetics is a big tick in green because you get the surface you need. Cost, again, is very, very questionable. The other options which are also trying to scale it in a two-dimensional method, first is to step it. So in section, you basically step it backwards. In plan, you can segment it in a single direction. Feasibility can be done, has some challenges because you will still have to go and seal the building from the outside, which at that height is a big challenge. Aesthetics would go for a toss from outside, even from a ground level. When you look up the building, you'll start seeing that stepping. And the cost would be somewhat reasonable. It will have its challenges. And then finally, one alternative, which was quite new for us at that point, was to actually fish scale it, where you have that little triangular portion that comes prefabricated as a part of one panel. So when it interlocks, it forms a unitized facade. Everything is questionable here. Feasibility, not many people can do it. Aesthetics, it will start creating a very reptilian skin-like geometry on the building. And then cost is again questionable because it's a very unique method of doing it. So our intention was to make sure all of them are green. It should not cost much. It should look great, and it should be doable by a large part of the market. So we're not just relying on a few contractors. So we looked west. We looked at a couple of our projects where we started exploring if we can actually bend a panel without involving heat or without involving thermoforming. So we looked at some examples of cold bending. The left building is a IIC by Frank Gehry in New York, and the one on the right is one of our projects in Dubai, which involves cold bending the panel. So the materials do not go through thermal deformation purely because of flexibility available in the material itself. You can actually cold form it into a specific panel shape, and then that gets installed. And this actually helps us tick all the three boxes. So we're not increasing the cost. We are ticking the box from of aesthetics perspective, and it's also feasible because we're actually using very standard components. So again, in this case, it was a big buy-in required from a large part of the market. Sealant manufacturers, glass manufacturers, aluminum extruders, everybody had to buy in that, yes, I can bend it. I haven't bent it before, but I can bend it and it works. I can still provide you warranty that the glass won't break, that the sealant will be able to hold the glass in position, etc., etc. So this was almost like going back to the entire supply chain. And based on the amount of stress the glass can take, based on the amount of stress silicons can take, whether the panel can hold itself up, we basically rolled the entire process backwards, and we came up to a number that you should be able to push a panel that's 1.5 wide by 4.3 tall by about 20 mm from one corner without having to do anything to that panel. You don't have to thermally form it. You don't have to triangulate it. It's a standard flat panel which can be pushed at the corner. Now, that 20 mm was agreed to by the large wide market, which means we're not spending more money to bend it or to push it out of plane by 20 mm from one corner. So purely based on that number, we then rolled it back into the design process where we said, okay, by 20 mm, how much of panelization can be achieved? So we basically looked back on how do we actually panelize it now? Based on that, what are the panel sizes that we get? So then the challenge was to actually start using the 20 mm warpability and then try and place the panels across. So we basically arrived at a panel module that was really optimum. It was allowing for 20 mm out of plane pushing at one corner. So that actually helps you cold bend the entire facade without having to do anything that's excessively expensive or not feasible. The other challenge, which I guess most of us are familiar with, is that trying to optimize something for manufacturing obviously involves some level of intelligence play where you try and increase repetition in your panels as much as possible, which works wonders for manufacturers, which works wonders for fabricators, where they keep coming up with same size panels. They don't have to keep changing their machine settings every now and then to switch to a new size. Logistics works really well. One panel breaks, you have 5 spares that you can start installing. So one thing that we thought that was useful as a part of the 20 mm play process was to actually look at panel groups. So the unoptimized version had all these gray panels in the middle as all unique panels. So there's no mirror or no cousin of it that sits there. So in case if one panel breaks or one panel arrives late on site, your installation stops. You do not move forward. So based on that 20 mm play and allowing the panels to stagger floor by floor a little bit, we basically could reduce the number of panel groups to 96. The repetition went up by double. So number of repeated panels from 951 went to close to 2000 plus. And the unique panels, which were all of the gray ones in the middle, they were close to 1,300. That came down to 164. So this sort of demonstrates the intelligence that can be used during design stages also has a play during construction stages. So it makes it more manufacturing friendly without having to compromise on the aesthetics. Plus, it should not cost you a bomb. So I think it's basically a win-win when you use the same level of intelligence during construction as well. So I think with that, I'll close my presentation. I'll hand it back to Khushbu.
That was really insightful, actually, Gautam. There was a lovely presentation, and we would love to see more of your projects in the future in India also. I would request Mr. Jinesh to actually take over and help us understand what all are the new innovation in materials that he has come up with, and we could all actually take some help from that.
Thank you so much, Khushbu ma'am. And first of all, thank you very much for having me on this panel. It's an honor to be on the panel with you all. And today's topic that we have been discussing on about the parametric design and methods is such an interesting topic. And I personally got to learn so much about it from all the presentations. So personally, I would like to thank you all for the same. Before, I'm a manufacturer of facade products, and before I get into the details of the parametric designs from the viewpoint of the product, I would like to discuss some reasons why parametric design is changing architecture in today's time. First of all, it brings advantage in both aesthetic and functionality of the project. It offers a powerful tool to solve visual, material and structural issues, and even though a purely functional process will still be infused with the designer's aesthetic vision, while architects have usually formed individual aesthetic aims of their own, their design will have to solve real functional issues, and where these new methods come into play. I believe today's time is the third industrial revolution because today's this third industrialization is one of robotics, computation, and mass customization. And architecture will need to adopt these new processes of scripting languages and understanding of these digital processes and manufacturing. Also, I believe it's not just a style or a word that, it feels good about. To us, style is always changing and following trends and fashion. I see this use of parametric design as tools and methods in process of making really high quality and innovative buildings for contemporary society. It allows us to manage complexities and dealing complex issues when we are designing big buildings or executing them. And in today's time, architects are integrating these processes into all the aspects of their work. And parametric architects deal with so many problems and so many factors like the program, through site context, user interfaces, environmental factors, material technologies, and manufacturing of it. It is a lot of work, and parametric design helps to manage all these factors. Manufacturing and material science. I believe that the research into material science and manufacturing methodologies is a growing discipline within architectural academia. like a basic example is like CNC machines, and how widely they are being used now, and opening up the possibilities for more adaptive design solutions. Like Khushbu ma'am also spoke about BIM. Most designers that really look hard at their future see that in one form or another, computational designs is inevitable part of the profession now, and BIM and other automotive methods are slowly taking over the standard office tools in today's time. And we are manufacturers of one of the most widely used facade products, that is ACP. We also manufacture HPL. And in today that we are talking about parametric designs, I would like to talk about the fabrication capabilities of a product, because it is really important that the product is versatile in terms of fabrication so that it can achieve the design of the building. Now, if taking forward, I would like to show some fabrication capabilities of ACP particularly. As you can see, this is a very basic method of cutting, saw cutting. You can cut ACP into any kind of shapes. It is CNC friendly. Being CNC friendly, you can get like infinite numbers of designs out of the sheets. And in today's time, I'm seeing so many designs where ACP is cut into different designs and are being used and looks very beautiful. Here you can see is that ACP can be routed and bended into different angles, which really gives a lot of options while designing the facade, that different curves and the different angles that can be achieved while bending this product. You can punch it, give this nice single punch or multiple punch, give this nice perforated looks to the sheets. You can bend it to different angles. There are different way of bending it also. You can see as the sheets are being bended into different angles. This is using the press brakes, and you can also bend it with 3-row bender. All this machinery are widely used by all the fabricators also. And as you can see, with all these capabilities, we can achieve these really good results. Like if you can see the CNC machine cutting, the different way of using ACP into a complex, nice design. So being a manufacturer of facade products, I always believe and want to produce materials that are fabricated, that have high capabilities while fabricating them, to show that now that the designs have evolved so much, the products can help in achieving those designs. Here are the some examples that I know I've seen and I take inspiration from these designs. This is the hotel in Abu Dhabi, and you can see how beautiful the building looks because of the parametric designing. This is one park stadium in Melbourne, and this is one museum in Mexico. And I am already seeing buildings in India, and I'm sure that now the designs, I'll be seeing more of such buildings in India as well. And we are also looking forward to manufacturing such products in terms of design and performance of the products, where we can be more and more helpful in achieving these kind of designs. So that's it from my side. Thank you so much.
Thank you so much, Jinesh. I'm really glad that TIMEX Group is actually helping manufacture these kind of versatile products for all of us to use in the panel. I would like to extend this question to Mr. Jinesh itself. How important do you think is different fabrication processes and innovation important in the future of architecture in India?
Well, definitely it is very important. As I mentioned earlier, customers' requirement have really grown up now, and so far the designs of the building have also evolved. Now we have this really creative and different looking facades in India. And so to properly execute these designs, our fabricators in India really have to innovate continuously by using more of machines for fabrication. And these days there are fantastic machineries available for sale. Now I often visit many factories of the fabricators, and they have really good machines now for the fabrication work. Also, these types of innovation saves a lot of time for the fabricator. In building industry, each and every day is very important in terms of saving cost. A delayed project will increase the cost. Hence, when we talk about completing the facade work on time, this fast and innovative fabrication techniques come into play. So I feel it's really important.
That's amazing. You were talking about mass customization. I love that word because I think everyone gets scared looking at a building which is, very unique looking, parametric. Everyone says that there will be a cost involved in this. So when you talk about mass customization, we are thinking of same machine, same technology, which we have been using for other industries, for example, automobile or aircraft. CNC machines have always been there in India. It's not a new thing. And I think we can use the same technologies, the same factories, the same kind of machinery is available in India to actually create buildings. I think the only construction industry has been lagging behind when it comes to using this technology, and just adopting, from all of these different industries, we'll be able to propel ourselves in the next decade. We're looking forward to the third industrial innovation. Taking that, and now I would like to ask a question to Mr. Gautam Bhasin. How has the industry, according to you, Indian industry evolved in the recent past with about fabrication technology and material innovation? Because you are into facade consultancy, I'm sure there have been issues with even clients thinking about getting a facade consultancy firm on board, first of all. So how do you think that has evolved in the recent past?
Well, it's changed quite dramatically. I think facade consultancy isn't older than 20 odd years or 25 years at best. I think the general awareness is improving as well, where I think clients have started seeing, or developers or owners have started seeing where the value is to bring a technical expert on board. And I think having that expertise on the table always helps you to make the right choices. As far as trying to find the right construction partners, the right kind of materials, the right kind of construction technologies. And that is in turn actually helping to raise the bar for the whole industry, not just for the design aspects of it. I think also the construction buildability aspects, where I think purely because newer age technologies where you rely less and less on site finesse, you rely more and more on manufacturing in the factory, trying to unitize it, trying to panelize it. So I think even the contractors are trying to raise the bar now, where they're trying to invest in highly sophisticated machines, double head cutters, triple head cutters, fully independent CNC machines, etc. So I think it's a tide that's now trying to raise all boats, as I would say. So I think everybody wants to be a part of that tide.
Right. That is truly interesting. That is happening finally. I'm glad. Mr. Ali Abbasi, I would like to point a similar question to you. While we are thinking of the evolution that has happened in the construction industry in the recent past, do you think the clients have caught up to it? Do you think the final user, the end user, has actually now understood the process and understood the importance of a designer and how pushing the boundaries of design can actually help?
I think that clients who are in the construction industry and have been around for a very long time, they understand the value of good design, and they understand that a good design, not only a good product gives you a good product, but also gives them a unique identity or something that differentiates their product from other buildings. So I find that it's the way it is presented to them and the way it is showcased to them. They definitely open to newer facades or newer different looking buildings, provided their basic criteria of cost and the financial viability of the whole exercise is kept within limitable, minimum damage for them. But I think that even the end users, when they see and when they experience and when they give feedback of those buildings to the developers or to the, it kind of gives them, more confidence, and it's up to us as well as architects to, to maneuver them to take them forward in that direction so that people start seeing the value of design. You know, when you have well-designed spaces and well-designed buildings, and the end user starts understanding the importance of design, which is very important.
That's true. So this is a slightly complex topic, complex when we are dealing with complexity in parametric design. I would like to ask all of you if any parametric building, whichever you've worked with, has increased the time, construction cost, and feasibility of the project. I would like Mr. Abbasi to continue.
I don't think so. It's increased the time because see, parametric facades, they actually give you a lot of advanced planning. They might increase time on the drawing board. They might increase a time on getting the the groundwork done. But once that is done, then it's like much easier process. And the way we go about it is we do a lot of mock-ups. So before we start execution things on site, we actually work where we try and do mock-ups. We try and do smaller scale modeling or sampling of what we want to actually achieve. And once that's done and it's okay in principle, the production of drawings and the execution of the project on site is very smooth because the accuracy that you will have with these drawings, whether it's CNC cut or whether it's molded and bended, it's all to a very high degree of accuracy, which otherwise would not have been possible. So I don't think it's increasing the time that it takes to construct. It might be the same time, but yes, instead of work on site being longer, maybe the work on drawing board is longer. So that kind of evens out.
Right, right. What about you, Mr. Bhasin? Does the cost increase? Is there a cost implication of a design which is parametric, which is complex compared to another building?
Well, I think I wouldn't compare apples to apples because I mean, I think now the trend is that you don't let the materials define what your building looks like. You want to choose what your building looks like, and then you design and optimize it based on the tool. So I think there is no other way to do it rather than trying to control your design parametrically, control your design from an optimization perspective. So I think it certainly saves time. Like Mr. Abbasi said that, it will take time for you to set up your tools, choose your tools correctly on the table. And then from that point, it basically gives you very good level of control with your design. And if done right and if dealt the correct way, it will give you very good control over the fabrication process as well. It will give you very good control over the manufacturing process as well. So I think investing time in finding the right people, investing time in finding the right tools, I think will take a little more time on day one, but it has rolling over savings in terms of time and both cost down the line till the building is complete.
Right. So to get to that kind of a very informed decision, what are your views on collaborative practice? They say there's a buzzword that collaborative practices are the future of design and construction. What are your views on that? Mr. Bhasin, if you could.
I think architecture as a practice has evolved. I think back in the good old days, and architect Parmar would certainly agree that architects had a good level of control on everything. They would detail out windows, they would do MEP, they would do HVAC, they would even draw electrical layouts. Now I think the practice has evolved that you have a kitchen specialist who comes in and tells you how to design your kitchen, or there's a pool specialist who will design a swimming pool for you. So I think the role of collaboration becomes even more important when you have finer stakeholders or that level of expertise available to you to basically control the design in a better fashion. So it almost is like symphony where you don't have a master or you don't have a convener who basically tells everyone what to do. And that in this case is the architect. So I think architects have now become more of a centralized role where they try and get the best from all stakeholders, maybe facade consultants or manufacturers or contractors. And I think that's where the role of collaboration becomes even more important. I don't think there's any other way to do it, but to do it collaboratively. And I think the tools come in very handy, where people are working on the same platform, exchanging information seamlessly, with information going back and forth.
Right. That's a great perspective. I would like to ask Mr. Gala, has the BIM industry evolved, and the parametric design tools can help the BIM industry and BIM technology to take it a step further?
Definitely, I personally believe it will, because when in terms of everything that we do, it gets we evolve with time in whatever we do. Especially when I talk about manufacturing products, even we have involved in terms of manufacturing, the way we manufacture, the way we test it, the way we look at it. The initial when I started business 10 years back, it was a very different scenario, and today it's a very different scenario. So I assume the same is with designing of the building. The practices used before and today are very different. Now we we have evolved over the time, so all our practices evolve with time. So technologies like BIM and everything has come at the right time, when our country is just booming with a lot of work, if putting the pandemic aside. So definitely all this new softwares and everything and this way of working is going to help a lot.
Great. I would like Mr. Parmar, can you let us know, what do you think about this, that we need to reevaluate our construction methodology? Like how you started the conversation. Could you give us a few words, conclusive words on this?
Yes, the construction methodology is already being reevaluated, and the research being done, and the materials being used, and the forms are there. I'm all for it, but I'm not for it just constructing something and making the monuments and just which are not very happy to live in, and just for the visuals. Just now we saw the very good, fantastic detailing of the tall tower which we saw. And the coordination of materials and combination of material and the form in terms of end of architecture, that is very, very good. And as far as possible, I would like architecture to be less plasticky as possible, and as much of Mother Earth visible as possible, and not to construct something for 200 years and which will occupy the thing. But I'm absolutely all for it. Whatever has been done and been presented by the architects at present, those forms. But anything which stands there and which is not necessarily it just stands by itself for its own personality and not for the environment, I'm sorry, I'm not for it.
Sure. We have to be mindful of our resources in the future, for sure. We could take a cue from some of the biomimetic principles. I think nature uses its resources to the optimum. It uses the least amount of resources, and the most amount of the structure is derived from the design. So I think, having said that, we'll conclude this seminar on this note. Everyone for coming and giving us your precious time. Thank you, everyone.
Thank you.
Thank you very much. We had a wonderful time here.
Thank you.
Thank you to our eminent panel for the colossal knowledge shared this evening. A special thanks to our sponsor, Timexbond. We thank our audience that have shown support and tuned in this evening. Until we meet again, stay safe and gear up for a new normal. Thank you.